So the first thing we want to do is to identify a, b, and c. So the general form of a quadratic is ax squared plus bx plus c. So we can just align this and see that, well, a is 2, b is 3, and c is 1. The two rules we're going to do in order to solve this is we need to find two numbers that multiply to a times c. So first, let's identify a times c. So a times c is 2 times 1. So we can see up here that a is 2 and c is 1. So that's going to be equal to 2. Then the second thing we have to do is that we need to find two numbers that add to b. So in this case, b is equal to 3. You can call this an MA table. M stands for multiply, so that's rule number 1. So finding two numbers that multiply to AC, which is 2. And then the second rule is add, and that's finding two numbers that add to b, which is 3. So what we can do on the left side is write out the factors of 2. So it's 1 times 2. And then you can also multiply two negative numbers to get a positive. So negative 1 and negative 2 are also factors of 2. And that's it. So now we add the two numbers to see if they add up to b. So 1 plus 2 is equal to 3. Negative 1 plus negative 2 is equal to negative 3. So we have found something that meets both of our rules. 1 times 2 is 2, and 1 plus 2 is 3. Perfect. So now what you do that once you have found the two magic numbers, which in this case is 1 and 2, you take your original quadratic equation and you'll split up the center term, so this 3x, into two terms, where the coefficient from the x is the magic numbers, so 1x and 2x. And then we can write the expression as 2x squared plus 1x plus 2x plus 1. You'll think about this as two separate terms. And you'll look at the two separate terms and see if we can pull out a common number. And in this first set, we can actually pull out an x. So what we'll do is we'll pull out an x, and what we have left is 2x plus 1. Because x times 2x is 2x squared, and x times 1 is x. And then what we have left is the second term. And we can think about this as a parentheses around 2x plus 1 and just add a 1 in front of it. And as you can see, now we have a 2x plus 1 in both of these terms. So what you want to do is pull that out, and what we're going to be left with is what's in front of the two sets of parentheses. So x plus 1. And this here is our final answer. For our next problem, we first want to identify a, b, and c. A is 10, b is 15, and c is 5. We know that we need two numbers that multiply to a times c. So a times c is 10 times 5, which is 50. And then b is equal to 15. So we can make our MA table. So we know the two numbers need to multiply to 50, and then they need to add to 15. So let's list out our factors of 50. 1 times 50, 2 times 25, and 5 times 10. Then if we add the two factors together, we get 1 plus 51, 51. 2 plus 25 is 27, and 5 plus 10 is 15. So we have found our magic numbers. They're 5 and 10. What we do now is we go back to our original quadratic equation, what we're going to do is split our center term using the two magic numbers. So 5x and 10x. So then we'll rewrite our quadratic expression as 10x squared plus 5x plus 10x plus 5. And then we look at the two sets of terms separately, and we see if we can pull out a common number or letter. So in this case, we can pull an x out of both terms and also a 5 out of the two numbers in front of the x's. And so what we would get is 5x in front of these. So that leaves us with 2x, because 5 times 2 is 10, and x times x is x squared, plus 1, because 5x times 1 is just 5x. Then, in our second two terms, we can pull out a 5. So we'll be left with 5 times 2x plus 1. And now we see that inside our parentheses we have a common set of numbers, 2x plus 1. So we can pull that out. And what we'll be left with are the two numbers in front of the parentheses. So 5x plus 5. So this here is our final answer. So for this next problem, let's start by identifying A, which is 5, B, which is negative 14, and C, which is negative 3. Then we want to first find A times C, which is 5 times negative 3, which is negative 15. And then let's identify B. So B is negative 14. Then we can make our MA table, and we know that we want two numbers that multiply to negative 15 and then also add to negative 14. So our factors are 1 times negative 15, or the inverse, negative 1 times 15. We have 3 times negative 5 and negative 3 times 5. Then if we add all these together, we get 1 plus negative 15 is negative 14. We get positive 14, negative 2, and 2. So we can see here that we have found our two magic numbers. They're 1 and negative 15. So now we can take our original quadratic expression and we can split the second term up into 1x and negative 15x. So what we get is 5x squared plus 1x minus 15x minus 3. So if we look at our first two terms, we see that we can actually pull an x out of both. So we'll get x times 5x plus 1. And if we look at our second two numbers, we see that we can actually pull a negative 3 out of both terms. So we'll have negative 3 times 5x, because negative 3 times 5 is 15, plus 1, because negative 3 times 1 is negative 3. Then we see here that 5x plus 1 is a common term, so we can pull that out. And what's left is what is in front of the two parentheses, which is x minus 3. So that is our final answer. So this problem is a little harder because our numbers are much larger, but if we follow the same rules, we'll get to an answer. So first, let's identify A, B, and C. A is 18, B is negative 33, and C is 12. So first we want to figure out A times C. So that's going to be 18 times 12, which is 216. Then we want to identify B, and that's negative 33. So now let's make our MA table. So we know that we need two numbers that multiply to 216, and then those same two numbers need to add to negative 33. So now if we look at our first factor, 2 times 16, we see this adds to 217. And notice that's a positive number, but our b is actually negative. So because our b is negative and our multiplication that we need is positive, we actually know that both of our factors have to be negative. That's the only way they'll multiply to a positive number and add to a negative. So this will limit the number of choices we have. So now I'm just going to write out all the factors of 216 up to 9 real quick. And then I'll write out what they add to. And voila, we found our two magic numbers, -9 and -24. So first step, we'll rewrite our original quadratic by splitting up this into -9 and -24. So we'll get 18x squared minus 9x minus 24x plus 12. So in our first term, we can pull out a 9 and x out of the first two terms. So we'll get 9x times 2x minus 1. And then we can pull out a 12. As you can see here, this time the insides don't match. So actually, we're going to need to flip. So we haven't seen this before, but whenever this happens, you want to flip the order of your two terms. So what I mean is instead of writing the -9x first, we'll actually write the -24x term first. And then we'll group again and pull out a common factor. So this time, what we can pull out is a 6 from the 18 and 24, and then an x from the x squared and x. So we'll have 6x, which will leave us on the inside 3x minus 4. And then the other two terms, we can pull out a 3. Actually, we'll pull out a -3. Since there's a negative here in front of the 9, that will leave us with 3x minus 4 on the inside. So now the parentheses are equivalent. So we can pull 3x minus 4 out. And what we're left with is 6x minus 3. That is our final answer. So for this next problem, it's a little tricky because we're missing a term. So the general form to the quadratic is ax squared plus bx plus c. And so what we'll want to do first is just add the x term by doing this. We can write it as 0x because that's the same thing as 0. And then our minus 5. And this can help us identify what a, b, and c are. So a is 5, b here is 0, and c is -5. So first step, let's identify a times c. So that's going to be 5 times -5, which is -25. And then now our b is equal to 0. So if we look at our MA table, we want two numbers that multiply to -25 and then add to 0. So we'll have 1 times -25, -1 times 25, 5 times -5, -5 times 5. What these add to is -24, 24, 0, and 0. So in this case, we actually have two options that work. However, they're equivalent, both 5 or -5. So let's take our original quadratic, and of course we can just write the 0x as a placement holder, and we're going to split this into 5x and -5x. What we'll get is 5x squared plus 5x minus 5x minus 5. And now from the first two terms, we can pull out a 5x. What we're left with is x plus 1. And then from the next two terms, we can pull out a -5, which leaves us x plus 1. So now the inside of the parentheses are equivalent, so we can pull that out and then write what's left over in the second set of parentheses. That's our final answer. Let's do an example where we have two different variables in the expression. So here, even though we have both x and y's, we know that our first term is of the order of x. So we're going to treat that as our main variable. And so for this case, a is just going to be 2, which we're familiar with seeing. Now b is just going to be what's in front of the x. So this time we have both a number and a letter, but that's okay. We'll write it as 7y. And then c, well, there's no x term, so it's just whatever is left over. So we have negative 15y squared. And so now, let's write out our rules. AC is going to be 2 times negative 15y squared, which is equal to negative 30y squared. So that's going to be our AC. And then our B is going to be equal to 7y. So now we can make our table. So M is equal to AC, which is negative 30y squared, and B is equal to 7y. So we know that two numbers need to equal to 7y, so we know that our factors are going to have y in them. So the first set of factors would be negative 1y times 30y. And when you add negative 1y and 30y, you would get 31y. And because b is positive, we want the positive factor to be the larger number. So, for example, if we just did 1y times negative 30y, we get negative 29y. And that's getting further away from what we want. So let's have the smaller factor be the negative. So let's look at negative 2y times 15y. Because the 2 times 15 would give us 30, and the y times y would give us y squared. If we add these together, we get 13y. So let's try another one. Negative 3y times 10y. If we add these together, we get 7y. That's what we want. So let's take our two magic numbers and go up to the original quadratic. And let's rewrite the middle term in terms of the two magic numbers. So we'll write this as 2x squared minus 3y, and then we don't want to forget our x, plus 10y x minus 15y squared. And then we'll group our first two terms, and we'll group our last two terms. We'll see in the first two terms we can pull out an x as a common factor. So this would give us x times 2x minus 3y. And then our second two terms, we can pull out a 5 and also a y. We'll say 5y is 2x minus 3y. Now we can see that we have 2x minus 3y inside the parentheses. So we can pull that out, and then we're left with x plus 5y. And that is the final answer.